let's get started. So, this is more for the recording, but last time when we did an install and setup of Java, I missed mentioning a critical difference. There are two parts of Java. I mentioned last time the Java Virtual Machine, the JVM. That is the Java runtime environment. Most people, when they're running Java programs, they install this. Okay? This just allows you to run Java programs. What we installed last time was the Java Development Kit, the JDK. This is what allows us to create Java programs. So JRE, the R is for run. JDK, the D is for develop. Okay? So this is to use, this is to create. And we are creating, so we use this. Okay? So I apologize for forgetting that last time. Let's spend a couple of minutes reviewing what we did last week, and then we will start on the new material. So, what is one of the major reasons why the JVM exists? Does anyone remember? Do you have Windows? Do you have Windows? Does she have Mac? Question for him. If I were to write a program in C on Windows, could I run it on a Mac? Correct. If I write a program in Java on Windows, can I run it on a Mac? Yes. Why? Yes, 맞아요. So the Java Virtual Machine was written for all of the different platforms. So PC, Mac, AOS, maybe not iOS, but yeah. Different versions of the JVM. So what you're downloading is a version of the JVM specifically for your computer. Okay? And then when we write code, it runs in here. And this acts as a layer of separation. So we just write for this. We don't care about this, because this handles that for us. Okay? Can anyone describe to me what this represents? We have a source file with Java code. We have some command. And then we have some binary file. Does anyone remember this? Yes, compiling. Okay? What is this called? Java C. What type of thing is Java C? You kind of said it already. Compiler. Yeah. So this takes your code and turns it into binary, which you can then run in the JVM. Okay? Cool. So that's good. What is this? Hey, welcome back. What is oh, I should do this otherwise. What is this highlighted text? Yes. What about the class? Yes, the name of the class. Okay. What does this program do? Yep. And if I want to run a Java program on the command line, what function do I need to define? I've defined it here. What's that? Nope. Begins with an M. Yes. Okay. If you don't define this and you try to run your Java program, nothing will happen. This is what, when you run your Java program, this is what is executed. Hey. Okay. Cool. That's probably enough to start with. All right. So let's get into new stuff. Now, actually, wait 1 second. This will be whatever version of the JDK was downloaded. Stand over here. Okay. Yep. But what I would recommend doing is you find it here, yeah. Find it here and then just copy and paste it. You don't need to close that. You can just go here. And then go to computer or C. Go to C. Program files. Java. Oh. Wait. Oh, sorry. Go back to C. Program files. Start typing Java. You don't need to type up there. You can just type here and it'll look through a folder by that. Nope. Only John D. Did you install it?
Yeah, I just did.
Are you sure?
It's
Yeah. So that's the installer. You need to run it.
oh, so once I run it, I remember.
Then
that,
it will
right.
unpack it with the files.
Right.
Hey, what's up?
I'm trying to get into Sublime.
Yes.
I can't find that file, but I got into Terminal. But that should be automatic, right?
Yeah, you just use terminal. You just use Sublime to write your code. You should be able to find it on Spotlight. If you type in Sublime, it should show up. Okay. All right. So, because holy crap. Because it is a new day and we're working on a new project, in my programming folder, I'm going to create a new folder. We're going to call it, we're in June now, so I'm going to call it June Variables. You can call it whatever you want. I just tag it with a month because we teach this class multiple times. Okay? So create your new project folder. And then in Sublime or Atom or brackets or whatever you are using, go to Project, add a folder to Project. You'll get a dialog box like this. And navigate to your new project folder. June Variables, there we go. Okay, now I have this empty folder. Okay. Right click, new file. I'm probably going way too fast. Alright. So I created a new folder that I'm going to do my projects in. Okay, I'm just going to do this again so you guys can see it. Alright. So I have this new folder. Okay. And up top here on Sublime, I go to Project. And I do Add Folder. And then you navigate to your new project folder. And you hit Select Folder. And then you'll see it pop up here. Okay. If you right click that, new file. Now I have a new file. If I hit Control S for save, or if I just go to File, Save, it'll prompt me to give it a name. I'm going to call it, I'm just going to call it variables.java. The .java is important. Not Kava. We are not writing Kava. I don't know what language that is. Okay? Sometimes Sublime will complain like this. You can just say, I don't care. Okay? So you should have some file like this and some folder like that. Okay? Has everyone got a new file? Are you bored to tears? I'm going a little bit slower because we do have new people who have joined us. So, 괜찮아요? Good. You're fine because you've done this plenty of times. You guys okay? You good? 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 Cool. Charlie, you guys doing okay over there? Alright. Okay, so our file name is variables. What should our class name be? Yes. Now, let's see who studied. Very close. Public static is right. You got them switched.
Void main.
Well done. And then what?
Strings. The bracket. Art.
Yep. 잘했어요. Very good. I'm impressed actually. It took me a really long time to memorize that. All right. So good. Now we have a new workspace. What are we teaching today? That's right. That's what we're teaching today. So last time we did something like this. You don't have to write this part. Right? We did this and it prints something to the screen. Right? Now, no matter how many times I run this program, it will do the same exact thing. This is not an interesting program. It will only print hello for all of eternity. Not interesting. So what makes things interesting? Data. Having data that can change, either from input or from collecting data from somewhere, or maybe even just changing over time by itself. That's what makes things interesting. In programming, we track this with something called a variable. It's a very literal name. Variable means changing. To vary is to change or to be different. So variable is something that is changing or is different. Okay? So we're going to define our first variable. Now, in Java, when you define a variable, you can think of a variable like a bucket. Okay? It stores some information, right? And that information can be taken out, put in, it can be changed, whatever. However, the variable must have a type. Okay? Because you need to know how big of a bucket you're going to need to put stuff in. If your bucket's too small, you try to put something in it, it's not a good bucket. If your bucket's too big, you're wasting space. Okay? So to prevent that problem from happening, Java has you declare what type of data you're going to store in the variable. In this case, for this first example, we will use an integer. An integer is a whole number, a number without a decimal point. It's int for short. And then we're going to call our variable x. Okay? Just for now, you can call it anything you want. It doesn't have to be x. It can be anything I want. Right? And then we're going to set it. Equals is to set something. We're going to set it to 5. And then we need a semicolon at the end of every statement, remember? This is a classic example of variable declaration and initialization. Those are really big words. Okay? Declaration is telling Java, hey, I'm going to have a variable and it's going to be this type. Okay? That is declaration. Initialization is setting the value for the first time. Okay? You can actually do these separately. You can do something like this. These are almost exactly the same. Okay? This is declaration. This is initialization. They can be done in one step. In one step. Wow, writing and talking at the same time is kind of a challenge. But we're not going to do that because it would complain. Why would it complain? You can only declare a variable within a context once. Okay? Don't worry about that too much for now. We'll cover that more by the end of class today. Okay? So this is how you declare a variable. Why would you want to do this? Let's demonstrate. Or, whoops. No. There we go. And I'm actually going to do this on a new line. What will this print? Tell me the exact text of what it will write. Anything I want and then what? Yes. Anything I want, colon, space, 5. Now remember last time when I was talking about strings, about text, and how we want to put it in quotes because then it's data, right? Because if it is not in quotes, Java tries to treat it like a variable. So this is the data containing the text anything I want. This is a variable, a bucket, called with a label on it, called anything I want, and it's storing something. Okay? When we put it like this, whatever is in that variable, we take out and we use. Okay? So this will print anything I want, colon, space, 5. Because that's what is stored inside anything I want. Sometimes, I'm going very slowly with this because sometimes when people hear this for the first time, they're like, what? This is actually kind of similar to algebra, like high school algebra, right? Whenever you did like x equals 10, y equals mx plus b, like it's the same thing. Okay? Questions?
So, the Java treats anything I want as a integer.
Correct.
And that one is just a quote, just a word.
Yes. Correct. So let's demonstrate this. What did I call it? June variables? Okay, so here's my variables.java. Actually, I'm going to get, not everyone is as fast as me on command line. In your terminal, navigate to, you don't know how to do this yet, do you? Navigate to your project folder. I'm going to run around and help people because it's difficult to remember how to do this. Are you guys still working on it?
We made until Java home.
Okay. You did Java home? Okay, perfect. Let me just verify real quick. Looks good. Cool. I'm going to copy that. And we're going to go to the path variable. We're going to edit it. And we're going to add another one, but it's bin folder. Because that is where the Java compiler is. And we want it to be available on command line. It's not super important to remember because you only need to do it every once in a while. So now, ta-da, you're good.
Oh, okay.
Yep.
So, do you remember yeah.
So this has to match this exactly. This is the input, and a couple of things. First off, no space here. So C, and then this function's name is print line. C, and we need some right. Right. Actually, that might be okay. I don't remember. Yeah, this would be okay. But this must be capital. Now we also want to save this file. And what is your variables? I'm going to do a capital V because that's good convention. And it must end in .java. Okay, variables.java. Now, this must, yeah, there you go. That needs to be a capital. There we go. Now, this must also be a capital S. Subword name. Alright, so the colors indicate which parts of, okay, so you know how in English or Korean or Chinese or whatever, we have different parts of grammar, like noun, verb, adjective? This is the name of your class, and these are the qualifiers for your class. This is the name of your method. This is the return type of the method, and these are the qualifiers for the method. This whole thing is the method's signature, which we'll cover today. Oh no! Oh no! So CD will just bring you back to your home folder. So if you look at your folder now, you went back. CD alone will send you back to your home folder. And no, it goes all the way back to the beginning. Yeah. So you want to do CD desktop L2 code, and then intro or 01 intro. Uh-oh. Maybe not these guys. Yep. Yep. Down. Yep. Good. Now jump on this. Yep. Yep. Oh. Uh-oh. Semicolon.
Come on, you should know this from C.
많은 semicolon이 있어요. Okay. So now I'm in this folder. Just like last week, we do Java C variables. Whoop. Except my window is not tall enough. There we go. It didn't print anything, so everything's okay. And now Java, and we just do the name of the class. Anything I want, 5. Okay? I know that sound and I know that look. Alright, what do you got? So we need to do Java C first, and then the name of the file. Also, here's what's interesting. If you start typing the name of the file and you get this tab, so now that we have an error. That must match the file name exactly. Well, minus 6. Yep. So save. Did you save? Yes. There you go. Now you can hit up to run to bring up the last command. Hit the up arrow. Enter. Good. Now do Java variables. Yep. So weird having to keep on it. Give me Brian Oniu. Ew. Right now. Sure. So let's look at terminal. We're going to see. Okay, so you compiled. You compiled it, but now you need to run it. This means like also just not find our main class variables. So she did it and did not save it at all. What means that? So that dot means that you've made changes and you haven't saved it. Just no means. So like if I do something like watch as X, that means there are changes between what's on the disk, what's been saved, and what's ready. So you wrote all this code and never saved it. So now do the same again. Oh, whoops, we need to compile it again. Now there's a problem. I cannot find symbol print len. Because the function len is not print len. What is the function len? ln. Java. So now we'll do Java. Yeah, that's programming. Now. Save. So 친구들이 using some Korean here. Something I want to make sure you guys... I don't say this because it is a part of my being. I don't even think about it. My hands just do things, and I don't tell them to, and they do them anyway. you should always, 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 every maybe 10 or 20 seconds, hit Control S. Or if you're on Mac, Command S. That saves your file. All right? Because we've had a couple of times where people have typed code, and then they try to compile it, and they're like, it's not working. Because all that code you wrote is not in the file yet. You have to save it. So save. Save, save, save. And then save some more. And if you're not sure, save again. Just keep saving. Okay? So get in the habit. Always keep your pinky, like when I hold up my hands, my pinkies stick out a little farther because I'm used to putting my pinky on the control key. Oh, I just lost audio. Oh no.
You need to Y on this one.
Yes, but this sounds so much better. Of course not. So yes, save all the time. Cool. Questions about variables?
Wait, so but there's not only integers. There can be like
Yes. Exactly. You are correct. So, does anyone remember what string is? It's okay if not.
Oh, it was that.
Our C guy should know.
Oh, do you know what string
Yeah, there. Well, in the yeah, but there's in the what is it? The standard. I guess he's only been doing raw C. Yeah, in the standard library that you can import, they have strings. So he's probably only been doing raw C, which, whoa, wow, pure C. Man, that's some fancy stuff. All right. I'm gonna be picking on him the whole class. I'm sorry. So a string.
I remember. I think I remember. String is when you want to like print out some like words.
Yes. When you think string, you should think text. Yep. Now I'm gonna get a little deep in the weeds here because we can afford the time. Too much stuff on the board. Okay. What would you call this? Sorry, like what would you call this or this or this or this? What would you call each of these? Character. Okay. Now, computers, they really only understand characters, which are really just numbers. Like this is equal to some number. This is equal to 4. This is equal to some number. This is also equal to some number. Okay? So when you're writing text on a computer, you're writing a series of characters. Why'd I... Another way to describe this is a string of characters. So a string in programming is a string of characters. Okay? So that is the literal meaning of string. Because English, programming is really hard for people who don't have strong English skills. Or harder. Because there are many metaphors in English that are built into the language, like class, right? That's kind of a metaphor, slightly. Static is also slightly a metaphor. It's not its absolute pure meaning, but yeah. So when you see string, you should think string of characters, which is text. Okay? So what if I want to create a variable? All right, here's a challenge. Charlie cannot answer, and you cannot answer. What if I want to make a variable, and you can't answer? What if I want to make a variable containing text, and I want the variable to be called monkey? What would I write? What type of data is it storing? I mentioned I want you to store text. What do we call text in programming? Huh? We just covered it. String. Okay? Now, that's the type of data, right? So using this as an example, what should I write? Nope. I just want to define a variable. Int is for an integer, but I want to store text. String. Yes. And then what did I want to call the variable? Yep. Ah! And what if I wanted to set it equal to bananas? What? Tell me the exact characters I need to type. What if I want to store the text bananas into the monkey variable? What would I type? Equals? Huh? Semicolon. Too soon. Too soon. Quotes, double quotes. And then what? Okay, now what do I write? There you go. Good. Okay. Now, if I want to print this to the screen, what do I write? Yep. And if I want to print the value, if I want to print the text that's inside the monkey variable, what do I write? Yep. It will substitute that text in directly. Okay? Control S because save all the time. And let's run it. Java C variables.java. I have to recompile it because I have changed the code. And Java variables. Bananas. B-A-N-A-N-A-S. My people who stayed in America know what's up. All right. Does everyone have that running?
Also, he's asking why don't we put double quotes on monkey this time?
Because if I were to do this, what? It would treat monkey like data, and it would print out monkey. Yes. If I do this, Java looks for a variable or a function called monkey. And in this case, there's a variable called monkey. So it substitutes that. Also, don't forget to comment, to leave notes for yourself. 'Cause you ain't gonna remember this next week. Alright? So leave notes. Leave notes in your code. You're not going to remember this in a week. Leave notes. And give people a couple minutes to write notes. Okay. Yeah. Quotation marks cause Java to treat it as data. Whereas if we just do a raw bit of text, it will look for a variable or function with that name. So this, when we write this, it's looking for a variable or function named monkey. If we do this, it will print the text monkey. And well, in this, because we're doing it inside a print function. This first part is really challenging because you don't understand what functions are yet. We're covering that next. Like as soon as people are ready. So it'll make a lot more sense in a minute. And by a minute, I mean like 60 of them. All right? Is everyone feeling good? If I want you to create a variable of type float for me, just accept that there's a data type called float, what would I write? Pick a name. You're no fun. Equals something. Right? Cool. Alright, that's just practice. Actually, there's one more thing I want to cover before we get to methods. So we've covered int. We've covered string. There are many, many, many more types of data. There's also Boolean. Yes. Boolean means true or false. Okay? This is useful to track the state of something. Like if you're making a radio, right? You might want some variable to track whether the radio is on or off. So you might use Boolean, right? You could do Boolean is on, true, or is off. Yeah, you get the idea. We covered string, which is not a basic type. We covered int for integer. Okay? There are other types. There's also float. Decimal. What is English? A float is dangerous. You know. So you see, when I talk about the low-level stuff, the C people get it, because this is like their world. A floating point number. This, right? So we have 0.5, right? This is a floating point number. It just goes, I'm going to put you here. The point floats. Okay? Now, the reason that this is dangerous is that a float only stores so many digits. Okay? So if I have some number like right, some really, really big number. It's just a random number. And let's say that the decimal point is here, right? Like, let's say this is a real number that I'm storing. Now I have to write the damn thing again. Ah. Okay. A float only stores so much data. Okay? So what it's going to do, maybe it can only store this many digits. I don't actually know. You can go look it up. But let's say it only stores this many digits. Okay? What the float is going to do is it's going to forget this. This will disappear. Gone. Okay? Yeah, that's why it's dangerous. And you'll get something like this. And it'll put the point like here or something. You use it when you need decimal numbers, but when you don't necessarily need something super precise. Okay? So that's float. Just be careful with it. If you do need very precise numbers, there's this data type called decimal. But if you're ever working on stuff where it's that important, you'll be doing a whole lot of research anyway, and you'll come across that yourself. So I'm not going to worry about teaching you decimal. If you need it, you will find it. Okay, so that's float. There's also double. Oh, float is you generally use it for low precision decimal numbers. You can also do something like 5f would also be a float, but it'd be the whole number 5. But you can add the f at the end if you want to. It doesn't really matter. There's also double. D. You don't need the D, but it makes it very clear. Okay? Double is much like a float, except it's twice as large. Because double. Okay? Charlie, what are my other primitive types? Char. Remember earlier we talked about string? You can have a single character. Yep. Char for character. Char, char, whatever. Some people say char. Now, notice. This is a single quote. Use single quotes for characters. Use double quotes for strings. They are two completely different types. Okay? You don't use character too often, though, so... Byte. Yes, thank you. Long. Ooh, wait. Huh? Long double? They don't have... Do they? Oh, they do. Yeah, very good. Wow. I forgot about that. I don't do low-level stuff that often, so I don't remember any of this. Byte is 8 bits. There's not a... Yeah, no. So a long double is a double that's even bigger. Okay. A byte. All right, we're going to get into a little bit of low-level stuff here because it's fun. It'll make our C guy happy. Also, you can make yourself look really nerdy. I was going to say cool, but it's just really nerdy to your friends. This is how a computer counts. This is binary. This is also a byte. Computers only understand zeros and ones, similar to when we were talking about those binary files earlier, right? So in the human world, we have how many digits? Right? So if I write the number 1, what it really is 1 times 10 to the 0th. If I write 10, it's actually 1 times 10 to the 1st. Right? If I write 100, it's 1 times 10 to the 2nd. Right? This is scientific notation. If people remember from like chemistry and physics and things like that. Why is this 10? Yes, because we have 10 digits. Okay? Deci is 10. We have 10 digits in our number system. So if in this notation, the first place is 0. The second place is 1. The third place is 2. Right? How many digits do I have in binary? Huh? Yes, 2. So I have 2 digits. This is the first place. Okay? So this is 2 to the 0th. What is this? What is this? Congratulations, you know binary. It's really that simple. The idea is simple. Actually, working the math is kind of hard. Fortunately, you don't need to do this that often. Holy crap, English. So when you see, it's not. Is it? No, crap. Charlie, how do I represent a byte in a binary in Java? Like, this is hex. X is hex. What's binary again? Yeah, I tried that. Binary literals. Holy crap. You never use it. Oh, it is 0b. Okay. But can you only do 4? Maybe Sublime just doesn't recognize it. I don't know. Let's see if this compiles. Yeah, long double. Yeah, I didn't think so. I was like, long double? That doesn't seem right. That's a C thing. There we go. Yeah. So sorry, long double is not a thing. That's a C thing. That's not a Java thing. Sorry, guys. So get rid of long double. But yeah. So this is how you write a byte. Now, here's the cool thing. Actually, wait, let me verify because I might be wrong. Oh. Hey, I didn't know that. Characters in Java are 2 bytes. I thought they were 1. Unicode, right. Thank you. Well, that answers that question. So that's not intimidating at all. You got an error. Oh no.
What does the error say?
Class name variable.
But you're not doing.
Oh. It should be Java C requires the file. Java requires the class name. So that's so why is this? Why do you care about this? The good news is generally you don't. Generally, it's not that important. But if you ever get into crazy things like big data, this gets very important. Because you want to use as little data as possible because you're storing lots of it, right? So you want to use the smallest data types. If you look, actually, let me just pull this up. Come on now. These are all of the Java primitive types. Did we cover all of them? Oh, that's right. There's long. That's long double. It's just called long. My mistake. I'm sorry. So there is a long type. There's also a short type. And then this is how much size each of them takes up. So Boolean is 1 bit. It is tiny because it's only true or false. It's a 1 or a 0. A byte is 8 bits.
Also on your computer, if you have like 8 megabytes, that's 1024 times 1024 bytes, which multiply that by 8 and you get bits, right? 16 bits, 16 bits, 32, 64, you get the idea. Okay? These are also the minimum and maximum values for these. Yeah. So this is just kind of good to know. Not super critical, but it's fun trivia. And now we should get into the meaty stuff. Any questions about this before we move on? F is character? Oh, yeah. Yeah. So if you, in Java, you can explicitly turn an arbitrary number into a float. And you do that by tagging an F at the end of the number. Really?
There is a D. There is. You're using a comma instead of. Oh, jeez. It's okay. Sorry. No worries. No worries. D is double.
Yeah. Now, why would you do this D or F? The good part is that in Java, most of the time you don't need to worry about it because your data type tells you whether it's a float or a double. But there's a few cases where you need to be really, really clear about what type of data it is. Now, a decimal number can be a float or a double. So you can use this F at the end or D at the end to be like, yo, I want this to be a float or I want this to be a double. Okay? So you can be very specific with that. Again, you don't use this very often.
What if you use like double decimal number 0.5 F?
Wait, say that again?
So for the float decimal number 0.5 F, instead of using the
Oh, if I did this,
or something like that.
I think it would autocast it. Oh, no, it doesn't like that. Oh, lossy conversion. So D double to float would not work. A double is twice as big as a float. So you have your double and you have your float, and you're trying to do this. Yes. So if we were to do a float into a double, that works. Because it's like, oh, you have something this big and you're trying to put it into a bucket this big. No problem. Okay. So yes, good question. Any other questions about this? Am I a code bender? Like Avatar? No, I'm not that cool. Alright. Cool. So let's close this. Okay? What? What? You can use Control W to close tabs. Let's make a new file. Okay? We're going to save it. We're going to call it methods.java. Going to wait for people to type. Methods.java. Can we cover? What's up?
Oh, you closed it. Okay, so you have it. Oh, you have it down here. Oh, but you closed the. Okay, so we need the project add folder. Two variables. Okay. There it is. And N for new file. Save it. Command S to save. Yeah. Give it a name. Methods.java. Yeah. Yeah. What's up? It's actually down at the bottom. It's a line. Yeah. Okay. Yeah. It's all good. That's actually poor UI design on their part. Because usually with good UI design, if you do a click here, it should do something near there. But it's like, no, we're gonna put it down here.
UI design in college. What? All right, so not you. You're too smart. My file name is called methods. Can anyone guess what I'm going to write? I'm sorry. We need to let other people participate. Yep, perfect. Good. Now, come on, let's see if you remember your beginner Java class. No? All right, Charlie, hook us up. Oh, baby, oh, baby. Well done. I don't know why I'm telling you well done. You could do this shit in your sleep. Charlie might be a Java developer. So this is cool. We have our main method. We know how to do variables, right? And we have this like system.out.println thing. Right? You don't have to type that. I just need to tell myself I'm pretty cool now and then. But what if I want to make my own method? I want a fancy method like that. We can do that. So we've actually technically done this already. We've already defined our own method. It's called main. But now I'm going to tell you how to define other methods. So you see these curly brackets right here, these two, correspond to each other, and they are for this main method. Okay. Also, you'll hear me use method and function interchangeably. They're effectively the same. So we can define other methods too, but they must be at the same scope. So they must be outside of this bracket, but inside the class, which is this bracket. Okay? So it must be in between the two. And now we can define our own method. We're going to make an add method. You can take in one number, you can take in a second number, and you can output a third number. So let's do that. We have to do this. I'm going to let you guys type this, and then I'm going to explain it. And then I'm going to let you mess with it and make it do silly things. Oh, and then that'll dovetail well into... Yeah, we'll be right on time, I think. Has everyone got this typed out? Give me a signal when you do.
So like, I use curly brackets whenever I want to define new method. So my first method starts from there because before that I'm just defining my class name.
Classes contain methods. Methods contain other code. It's a nested structure. Yeah. Let me know when you've got this typed. That likely means that we're running either different versions of Sublime, or that you might have a typo somewhere. Or I might have a typo somewhere. But I don't think I do. I'm going to fix my headset real quick. So everyone's got this written out? Yes, 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 cool. All right, so what the hell is happening here? First, static, ignore that. We are not covering that today. That requires a whole lot of other knowledge that we are not ready to give you within 2 hours, okay? So forget static for now. Public. This is an access modifier, okay? There are 4 of them. That's not 4. That's 4. Okay? Sabon, right? Can I count? Or no, I'm counting. So it would be Nippon, right? Nah, I don't know Korean. I'll stick with English. How to do that? Yeah, whatever. So there are 4 of them. There's, man, you freaking binary, get out of here. There is public. There's, protected. There's default, which is nothing. And there's private. Okay? Public means anyone can use this. Anyone, anywhere, in any code can call this method, assuming that they have this library available to them. Okay? Protected, we're not going to cover that today. Default, we're also not going to cover that today. I apologize that we have to skip so many things, but I don't want to overload you. And then private means no one can touch it. Only this class can use it, so it can only be used internally. Okay? So we could make this private, because we're only using it inside the methods class. And that's probably actually the right thing to do. You generally want the most restrictive access modifier you can give. But I'm being lazy. Whatever, it's fine. Actually, no. We'll be good citizens. We'll make this private. Okay, so you have your access modifier. For now, you have to add static. Just accept it. Again, we'll cover why later. Then is the type of data being returned. So remember how a variable has to have a type? Right? Functions can output, they can produce data. And that must also have a type, just like a variable. Okay? Now, so why do we have void here? Void means it does not produce any data. Void is the absence of things. There's nothing. So when we say void, we mean we're not outputting anything. You can call this function, but it won't give you anything. It may do things, but it won't output anything to you. When we put a data type here, the function must produce some output. So I can use this function and it will give me something that I can then use. This is the name of the function. Just like a variable name, it can be whatever you want. Now, a note on naming. You should always name your things descriptively. Okay? X is actually a terrible name for a variable, unless you're doing something in like a coordinate system where you have X and Y and things like that. Add is a pretty good name. It means we're adding things. It's very clear what it means. Be very specific with your names for variables and methods. If you're working on a project with anyone, they'll thank you. And you'll also save yourself time, because if anyone else is working on your code, they can just read it, and they'll know what it does, because they can read. If they can't understand your code, they're going to have to bother you and be like, hey, what does this mean? You'll have to go, it means this. Now let me work. All right? And then what's inside the parentheses are our inputs. Data that we give to the function so the function can do something. You can think of a function kind of like this. You give it some number of inputs. And it produces some outputs. Maybe. Actually, no, that's confusing. Maybe. Optional. Okay? Sometimes it's void and it doesn't produce anything. Okay? The inputs go into the parentheses. This is exactly like a variable declaration, because it kind of is. When the function is given inputs, it stores them into these variables. So this is kind of like a variable declaration. Now, a function can accept however many inputs you want to give it. There's technically a limit, but if you're anywhere near that limit, you're probably doing it wrong. You separate inputs with a comma. Okay? And then this whole thing is called the function signature. Okay? This must be unique for this class. What that means is I can't do this. Ah! This will not compile because these are the same. If anything about, well, if any of this part is different, it will compile. But since they're the exact same, it will not compile. Okay, so that's this is the function signature. This is the function body. Okay? So when we use this add function, whatever's in here is what's going to happen. Okay? That's a lot of information. Okay? Functions are a little bit complicated for beginners.
So body doesn't have to be unique.
Correct. Body can do whatever you want. As long as it is code that will compile, you can do whatever you want in there. For good or for evil. All right. Questions about this part so far?
Well, like what if you write like really elaborate code and you might want to reuse the function signature? Does that happen?
How should I answer that question? I'm going to ask you to hold on to that for a minute, because it's not a valid question, and you're going to understand why in about 5 minutes. Okay? Other questions? Yeah. Yes. Can be used by other classes. Yes. So if another class creates a methods object, it can use the add method from that object. We haven't covered objects yet, but you seem to understand these things, so yeah. Other questions before we do a little more? Okay. Now, what I've written here. Oh, whoops, sorry, that's the wrong file. We want methods. There's nothing about add. Right? We did all that work defining that add function, but nothing's happening. What this does, this only defines a function called add. We have said that there's this thing called add and it does this. We haven't used it. Okay? This is a function definition. Okay? We have not done anything with this function. It's available to us, but we haven't used it. If you want to use it, you can do something like this. To use a function, to use a method, you call it. When you call someone, right? When you call a person, what do you call them by? Oh, maybe not in Korea. Ooh. At least in English, when we call someone, we call them by name. So when you call a function, you call it by its name. I know in Korea sometimes you use title instead of name. Oops. But in programming, when you call a function, you call it by name. Okay? Oh, hey, did it do? Oh, check that out. It even tells me where it was defined. That's cool. And then you do parentheses. This tells it that it's a function call. And then you provide the inputs. These inputs are what's called positional. The position of the input in the call corresponds to the position of the input in the definition. What does that mean in plain English? The first value gets set to the first parameter. The second value gets set to the second parameter. Okay? Simple. Questions about that part? Correct. We've technically done that here. So when this function runs, the first thing it does is it takes this input and it assigns it to A. So kind of in the background, it does something like A equals 2. Okay? Does that answer your question? Cool. Now, what will this do? It's kind of a trick question. Return 4, yes. But return it to what? Nothing. This logic will run, but nothing's changing because we haven't printed anything. Okay? So what we can do, so this produces a value, right? This will output, oh, right, sorry, one last thing. I'm sorry, I forgot this. Within your function body, okay, if you have a return type, you must use this return keyword. Whatever is after return will be the output of the function. Okay? And it will stop the function there. Okay? So if I write code down here, it will never execute. Okay? Because the function finishes as soon as it hits return. All right? Now, so that means that whatever a plus b is the output of this function. It's an addition function because we named it clearly. So we can actually, you know how you can do like int my number equals 5? Well, that's not an equals. You know how you can do something like that? 5 can be anything. It could be another variable if another variable existed, right? Or in this case, you can do this. People be like, what? So what happens is, it actually kind of works from left to right. Or really, from parentheses on the inside, right to left, whatever. Java will see this, and it will execute this function. Okay? Since this function returns an output, it'll calculate this, right? The output in this case will be 4. And then this gets replaced with 4, because that's the output of the function. All right? And then we store that into the mySum variable. All right? And then we can print that. Oh, are we ahead on time? Not quite, almost. We're still about right on time. So now that I'm printing something to the screen, actually I'll give people a minute to write this. Okay, has everyone got this down? Yeah? Okay, cool. Now, if I run this, it'll print my sum is 4. Just as predicted. Okay. Other questions? My sum is a variable. Okay. Add is a method. Add is being executed. And then the output of add would be substituted here. And then that gets stored into my sum.
So the system out println the first one and the integer my sum second one and system out they're all main methods that
They're all within the main method, yes.
main methods and we made another curly bracket to make our what was it function signature.
This,
The main method
so this whole thing is a second function.
second function.
This is the first function. Okay? I mean, there's no real order to the functions. They can be in any order you want. So this is just another function.
But we always have to make new bracket to like declare a new method.
Yes, the brackets define a context. So there will be other. So we have a class creates a new context. Methods create new contexts. There's other things that also create new contexts. When you declare an array for a raw array, it'll create a new context. If you define a condition, it'll create a new context. It's a common thing. So what is in between these curly brackets is a context, and it belongs to whatever is immediately before it. So that's why this is the signature, and then there's this, or you can this. Actually, thank you for bringing that up. Another word for so this is the function signature. It's also called the function head. So this is the head, and then the body belongs to the head. That's another way to think about it, if that's a little easier for you. Okay, good. Good question then. Other questions? All right, my friends. I have a challenge for you. I want you to define a subtract function. And I want you to use it. And I just want you to show me that it works. Okay? So define a subtract method. I'm intentionally switching back and forth between method and function now, because they're the same. So define a subtract method, and call it, and print its output. Okay? I'm going to write that up here. You have 15 minutes. Hopefully it won't take that long. Okay, Google. Okay, Google. Set a timer for 15 minutes.
Wait, but I don't know the name of subtract method. Abbreviation?
Define a method named subtract.
Subtract?
Yes.
Is it,
Actually, yeah, I'm just going to leave it subtract method. Define a method that does subtraction. And if you're using good naming, you should probably also call it subtract. Also,
Java, class name should match with your file name. So yes, letter one should be renamed, okay? Yes. And then when we choose to hey Beach, so Alex just text me. That's it. You know together? We'll dinner plan. We'll dinner plan. Yes. Alright. So I was about to ask you. You asked me.
You can forward on. I'm hoping on the last one. One of the wonderful things about being close friends with someone who spent significant time in the States is that I can tell you metaphors that you will understand in Korean as well.
Which metaphor did you just use? Didn't get it.
Read between the lines. Read between the lines.
I know I'm using do this.
Yeah.
Oh, I'm good.
So,
Yes. So you have not compiled it. Compile it one time.
B-I-R.
Yes, so you have to compile it one more time. We did this great. It's alright. Java AC.
Got it? Yeah.
With AC. And then methods. And with this that. Space. Dot Java. And then there's something wrong with your
It takes some practice. Practice.
or you should not use like this.
한국말 subtract 어떻게? 빼기? So like
Oh, yeah. You
It's
have an engine.
빼
어.
double view
You start with the parentheses.
Oh.
You need to do parentheses.
and 빼
Wait,
and
semicolon.
key.
And let's save it again. Save and go back there and
Set it
file
in.
again. Java AC. And you don't have to DR.
even that word is hard. 일어나요. 일어요? 일어나요? 일어요. 일어요.
C
일어요.
and then man.
일어요. It's hard.
어려워요.
어려워요.
That's good.
어려워요.
That's good.
어려워요.
See, and
Hard.
just explain it. Now the VIR. C what this means.
어려.
Then created class
어.
file, right? And then
요.
to run them.
어.
Java. Space. Space and then methods. That's it. You don't have to have class.
Egg.
Just
Egg. 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 Okay.
What does Java method means? Okay, I'm gonna run the name of the file. Say class
File one to
file.
Variable name is custom.
This
Within a
file.
context.
This file.
create.
Create it. That's right. Which you usually need to compile the file. Okay. Okay, ask me. Any question? There's no specifications. Okay.
weeks, we'll start introducing Java, and that will be after this class. So if you like know most Java things, but there's still some stuff you're like kind of, you can do both classes. Assuming at 6, yeah, which will be after this class, but 2 weeks. Tuju. Tuju? Too many.
How would I? Hi Google, give me the power of language. Translate. That is not magic. Love it. Yeah, Tuju. Okay. Right.
이주
Yeah, all right.
Can you hold?
Yep.
Yeah, we're getting
Evil. What does this correspond to? So this is the end. End. Where's the beginning? End. Beginning 어디예요? 맞아요. End and beginning. Okay. Where does this one end? So can I give you a tip? 맞아요. 그리고 if you do this, it's easier for your eye to see end, beginning, because these line up. Good. Are you bored?
We're still getting errors.
Okay. Okay, good.
We're still getting errors.
Okay. What's next? Return outside method. 이번 statement 아니에요.
This is so confusing.
So, quick note. This is not a statement. We have not told the program flow to actually do anything. So there's no semicolon here, and there's no semicolon here. Okay? Now this can contain statements, right? Which is why there's a semicolon. But this itself is not a statement. So there's no semicolon after the head, there's no semicolon after the body. Okay? Who is finished?
Oh, I'm finished. He wants to CD review.
CD, change directory. Okay. So everyone or most people got this running? Cool. I can help you at the end if you need, or Charlie can help you. Good job. So just to review for the video, if we wanted to define our own subtract method, it's going to output an integer, so we're going to do it like that. Ooh, actually, yeah, it's going to output an integer. We're going to take in two integers. We can reuse these variable names because they're in a different context. But if you want to be super, super picky, you can also just do C and D, whatever, doesn't matter. And then you just return C minus D or D minus C, whichever, I don't know, this makes more sense to me. And then you just do, if you want to be super fancy, you could just substitute it in directly. Subtraction, I guess. We're also going to do this. And then, ta-da. Oh, I should have put a space. Space. There we go. Cool. Good job. Now, one last thing before we call it a day. You want to see something crazy? Something absolutely absurd? This works. Remember how I said that this part has to be unique? Actually, this part has to be unique. Right? So we can have two add methods. If they accept different parameters, that's okay. You can even do different types. For example, we could even do yeah. Trippy, right? That all works. It will compile. I won't bother calling it because if it compiles, it's fine. Well, I compiled it twice because I really wanted it to compile. There we go. So that works. This, when you have multiple methods with the same name, is called overloading. Okay? That's a vocabulary word that you should remember. Because we have some method and we have overloaded it. Something you'll often see when you do overloading. This method is using this method. It's a little bit confusing, but it actually gets really, really useful. Because if you have a method that, these are all one line long methods, but if you have like a 20, well, 20 might be too much. If you have like a 10 line long method, if it's more than like 10 or 20 lines, you may want to split it up. Depending, there's always exceptions. And you have one with different inputs, you don't want to copy all that code again. All the parts that are the same in the two methods, you can just call the other method from inside it. Make things faster, easier. Okay? So this works. Questions? I see, yeah. Yes, because of this. Yeah. If we were to do this, it might not. I don't know if this will actually compile. Oh, whoops. Huh, okay, so it compiles. Will it run? Yeah, it'll run. Oh. Watch this. Actually, here we go. it's assuming they're integers. This will break. Okay. And if we do this, actually here let's get fancy. Actually, this won't compile, will it? Yeah, because it produces a float. Oh, let's do this. Let's actually do this one. Because an integer can go to a float, I believe. Yeah.
Is that the same logic as small?
As the double, yeah. Yeah, because this is an integer. That's okay. An integer is smaller than a float. Yes. Crazy autoboxing stuff. But we can also do this. We can explicitly tell it, do floats. Then it picks the correct one. Types are crazy. Okay? So, when it's just this, Java will, the first thing it will do is assume they are integers. Okay? And it will look for the corresponding method. Okay? In this case, it finds one where they're both integers and everything's cool. All right? However, if we didn't have this, it would still work, but it would use the floats one. It's a little bit confused. Ooh. Oh, that's failing. Let's do this. No. Okay. Even though it's integers, it will automatically cast them to floats. Okay? But it can't go from float to integer. Right? But in this case, it's okay because we have a float version. Okay? Does everyone understand that? Cool. Other questions? I see the gears turning. Where the floating point is? You can't. Java does that for you. Yeah. Actually, you cannot control it, but you can predict it. It goes out the most significant digit. So if you have a number like this, it'll start storing here because these are insignificant. Okay? If you do something like this, it'll start storing here because this is the most significant digit. And this might get cut off. Okay. Does that answer your question? Cool. Other questions? Yeah. I am up all the way. Oh. Wah! How's that? Is that good? Is that what you're looking for? Cool. All right. Yep. I think I commented it on the meetup. I hope I did. I plan on doing the same as soon as this video is done. Because Korea's internet is really fast. Korea's internet is so awesome. U.S. internet sucks. Picture? Wait, what? Wait, so you want one more time?
If I want to create some picture,
Uh.
then I will use the print out,
Right. So when you do system out print line, out represents this console. No pictures here. Picture 하지 않아요. Can't do pictures here. Okay? Only text.
Since it's CM,
Yeah. Yep.
but what if I want to present it graphically?
In a window? That's much more complicated. We actually are not going to cover that in this class. That is a very rare case. These days, desktop applications just aren't as popular as they used to be. Huh? Oh, sure they were. Back in the day, there used to be plenty of Java, like AWT stuff. I mean, when I was in college, we did. Sorry, not AWT, Swing. I was getting them confused. I'm sorry. Yeah, everyone used to use. So Java has a couple of window libraries, AWT and Swing. Swing is the more popular one for a good reason. It's just nicer to use. I think it might perform better too, right? I don't know. It's been a long time. But generally, yeah. Generally, there are more tools to build a web server with Java, and then you could serve up images on your website. And the tools to do that are really easy. So, well, once you have basic Java knowledge, which we're giving you here. So, we won't cover it in this class. We won't do images in this class. When we start transitioning from beginner Java to intermediate Java, we'll cover building a web server from scratch, and then you could do images that way. Yeah, if you do want to make a desktop application, like an application that runs on your computer directly that has windows that you can put images in, you want to look up Java Swing. Java also has an OpenGL library as of a few years ago, but I've never touched it. But Minecraft is written using it, so it's definitely a thing. It's just not very common. So the short answer is I don't know. Good question though. Look up Java OpenGL, look up Java Swing. Or if you're comfortable just doing it on a website, eventually we'll get to building Java web servers. Cool. Other questions? Cool. Well, thank you for coming, everyone. Yay! Next week we will be covering conditions. Yeah, next week. Oh, we're doing both? Wow. Next week we'll be covering conditions and loops. If this, then that. And, I want to do this 200 times using 3 lines of code. So we'll be doing that next week. And also, we sent out a survey like just a few hours ago. So you should give us feedback and tell me I'm awesome or I suck. Or what's more useful, how can I be better? Or if you want the class to be different somehow, or if you want to study different things, or put that in the survey. Should only take you like 5 minutes. It's like 3 pages. And only one of the pages has more than like 2 questions. So, yeah. Cool. Thank you for coming, everyone. All right. Yeah. Give me just